Okay, this problem says a container is filled with oil and fitted on both ends with pistons. The area of the left piston is 10 millimeters squared. That of the right piston is 10,000 millimeters squared. What force must be exerted on the left piston to keep the 10,000 Newton car on the right at the same height? Pause the video, try your best, and then I'll give you some help. All right. This problem is about Pascal's principle. So let's recall what that is. It says a change in pressure applied to an enclosed fluid is transmitted undiminished to all portions of the fluid and walls of the container. The implications of that would be that pressure on one side, wherever it's applied, should be equal to the pressure, or should result in an equal pressure on some other side. Here's a simulation showing Pascal's principle. So what it says is if I apply a mass, if I drop this mass here, it will increase the pressure here. And let's see if you get the same amount on this side. They are far apart. They're connected, right? Same container. If it's far, different shape. So let's see. And as you can see, you have the same change in pressure. So a pressure here is equal over here. Because we know pressure is force divided by area, then we can say force 1 over area 1 equals force 2 over area 2. And you can think of this as left or right, and I think most of us will be able to solve this problem with this information. Now let's just plug in what we know. We don't know the left side force, we know the left side area, and we know everything on the right side. The left side force was called just F. Area 1 was 10 millimeters squared. Force 2 was 10,000 newtons. And then area 2 is 10,000 millimeters squared. So because of these two numbers, as you can see, they're the same. So that's going to give us 1. And most of us can see the answer already, but if not, let's just solve. So then I would have to multiply times 10 millimeters squared. So let's cancel everything we can. We end up with newtons. That's exactly what we want. 10,000 over 10,000 is 1. 1 times 10 is 10. So force required is 10 newtons. Think about that. You need 10 newtons, only 10, here to hold a small sized car. That means if you had a 3-pound dumbbell, 3 pounds, you could hold, using a hydraulic press, a 2,300 pound car. Think about that. 3 pounds to hold a 2,300 pound car. All right, question 2. Imagine holding 2 identical bricks underwater. Brick A is just beneath the surface of the water, while brick B is at a greater depth. The force needed to hold brick B in place is, pause the video and try. Okay, to answer this question, first of all, some of you might have thought, okay, B is at a greater depth, therefore it needs more pressure. However, in this case, you have to think of buoyancy or buoyant force. The force against which you're fighting is the buoyant force. So the question is, which one requires, or which one would have the greater buoyant force? If one of these has a greater buoyant force, then that means it would require greater force for you to hold it in place, or in this case, B. If B requires more buoyant force, then you need more force to hold it in place. So check it out. I have this liquid, 2 identical cubes. Now, let's see how much buoyancy both of these have. So they are the same. The reason behind it is because they're identical. They are displacing the same amount of fluid, which means the buoyant force, because buoyant force is the weight of the displaced fluid, would be the same, okay, because they're identical. All right. Question 3. A boat carrying a large boulder is floating on a lake. That's a big rock. The boulder is thrown overboard and sinks. The water level in the lake, with respect to the shore, rises, drops, or remains the same. Pause the video and take a guess. Okay, to show the explanation for this video, I'm going to use a simulation. And I don't have a boat or a boulder, but I have a wooden box or cube, and then an aluminum object. So what I'm going to do is I'm going to move this object, drop it, and then it is going to sink. And we need to see what's going to happen with the water level. So let's write it down so we don't forget. Right now we have a volume of 106.10 liters. Let's see if the number goes up, goes down, or stays the same. And as you can see, it dropped to 104.40. Why is that? Well, when you have the object on the wooden box or the boat, it is displacing its weight. Because it's pushing with its weight, it's pushing down on the boat. So the boat has to account for that weight. It reacts with normal force. So then there's an additional force here being applied, which means this object is displacing its weight. And when I drop it, it's no longer displacing its weight, but it's only displacing its fluid. Because in this case, the weight, right, the weight has a greater effect because it's on the on the boat, and on the boat having a greater volume, displaces more fluid. When it's off the boat, then it only displaces its volume. Think about it this way, another way. Let's say you had let's say a marble-sized object of something very, 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 very dense, that is very heavy. Okay? Let's say you could have a material, and just for the sake of argument, you have a marble-sized object whose mass is 10,000 kilograms. If you were to throw that small marble-sized object into the lake or into this container, it would displace a very, very, very small amount of water. So it would do almost nothing to the water level, right? Because it's so small. However, if you were to place that object, let's say on a big, big boat, well, because it's very heavy, it would displace a lot of the boat's volume, so it would have a greater impact. Hopefully that made sense. Question 4. 2 cups are filled to the same level with water. One of the 2 cups has ice cubes floating in it. Which weighs more? The one with, the one without, or the same? Pause the video, take your guess. Many of my students have said in the past that the one with ice cubes would be heavier. I guess they think they have more stuff. And another group of students, they said no, the one without ice cubes because it has more liquid. The thing though is the ice cubes are displacing their own weight in water. So that means both glasses would have the same weight. If you don't believe me, test it out. You'll see it is the same. All right, last question. Consider an object that floats in water but sinks in oil. When the object floats in water, half of it is submerged. If we slowly pour oil on top of the water so it completely covers the object moves up, stays in place, moves down. So for this one, I couldn't find a simulation to do this one, so I'm just gonna show you how I tested it out, and hopefully the result agrees with your answer. And as you can see, the object moves up. And that's it.